Welcome students. So continuing here with the next preparation reaction for the amines, which is Gabriel-Thalamide reaction. So in the Gabriel-Thalamide reaction, the main objective is to prepare the primary amines. Okay, the primary amines means the general formula will be RNH2. And in the primary amines, the Gabriel synthesis involves the reaction of potassium hydroxide with the thalamide. Okay, so what is thalamide? I will show you then, which is undergoing a nucleophilic reaction to form an imide ion. Now this imide ion attacks the alkyl halide by using the nucleophilic substitution reaction and leads to the formation of an intermediate compound, that is n alkyl thalamide. Sorry, n alkyl thalaimide. Now this thalaimide then undergoes hydrolysis, which yields primary alkylamine, and however aryl amine cannot be prepared through Gabriel synthesis because aryl halide do not undergo simple nucleophilic substitution reaction, and Gabriel synthesis has an advantage of eluding the possibilities of over alkylation of our amines here. Okay, so here we will obtain primary amines only, and no secondary or tertiary amines can be formed out here. Next, what is the procedure for preparing the thalamide, preparing the amines, primary amines from the thalamide reaction? So here, generally what happens when thalamide, okay, thalamide means what? Thalamide is a benzene ring which is been attached to two carbonyl groups, and these carbonyl groups are attached to the NH. This is thalamide. Okay, so first we have to prepare this thalamide, and for preparation of this thalamide the process is that we have to we have to first react the thalamide with the potassium hydroxide. Then it is further reacted to alkyl halide, where we will see that the negative nitrogen which is acting as a nucleophile here, and it will attack with the carbocation of the alkyl halide to form here n-alkyl thalamide. Okay, n-alkyl thalamide, n-alkyl thalamide. Then further, this n-alkyl thalamide is reacted with the hydrazine. Okay, this is one method that we are reacting the thalamide with the hydrazine to produce the thalamide and primary amine here. Okay, so this phthalic acid, so this is thalamide which is produced with the primary amine here. Okay, so now what is the mechanism by using which we are obtaining this primary amine here? So here first, in the Gabriel synthesis we will see that we will observe that the thalamide, P-T-H-A-L-A-M-I-D-E, thalamide, it is reacting with KOH. Okay, so here KOH, it is having K plus OH minus, and here the deprotonation of thalamide will take place. Okay, in the deprotonation, the nitrogen and hydrogen bond here, it will break up, and the hydrogen, it will react with the hydroxyl ion of the potassium hydroxide, and it will form water here. Okay, water will be released out here. Now, as the negative charge is present on the nitrogen here after the removal of after the deprotonation, then the K plus will form an ionic compound here, that is potassium thalamide. Okay, potassium thalamide. Okay, thalamide. Okay. Next, then this potassium thalamide, it is been further reacted with one molecule of, it will be further reacted with one molecule of the RX here, that is alkyl halide. So here again the nucleophilic reaction will take place. Here the nucleophilic substitution will take place, and the K plus or the positive potassium cation will be replaced with the carbocation of the alkyl halide group. There, the nucleophile nitrogen will the nucleophile thalamide will react with the carbocation of the alkyl halide here, and it will form the compound that is N alkyl thala thalamide. Okay. Now further, this N-alkyl thalamide, it is further been reacted with the hydrazine. Okay, it will be further reacted with the hydrazine there. So here at hydrazine, what will happen? The oxygen here, due to the presence of hydrazine, okay, it will undergo bond breakage with the carbon atom, which is having double bond, and also a lone pair of electron will be donated here to form another double bond here, due to which the bond line will open up here at this point. Okay, at this point we will see that the pentagon bond will be open up here, and here the attachment of the NH2 ion will take place here. Okay, so here we will see that we have formed out the nitrogen of thalamide participates in the deprotonation of the protonated hydrazine here. Okay, the formation of protonated hydrazine which will attach to the thalamide will take place here, and here the nitrogen will again obtain a negative charge which is attached to the alkyl group. Then further, this new intermediate compound, it is been undergoing rearrangement here, and in the rearrangement the bond between the nitrogen and hydrogen, which was one extra protonated hydrogen, was attached to the nitrogen, that is the hydrazide here. So it will break, and the negative charge of nitrogen, it will attract this hydrogen to form a bond between them. Okay, so here one more adduct compound will be formed out here, where the nitrogen is connected to the hydrogen, and it is connected to the alkyl group here, and also the hydrazine is still present with the compound here, thalamide. Now further we will see here that on hydrolysis, okay, on hydrolysis, here the placement of the NH, okay, the placement of the NH, it will change, and NH2, okay, sorry, the placement of the NH2, it will change here, and it will attack the position of the carbon atom which is having more positive charge, and it is attached to the oxygen here. Due to this reason, what will happen? This RNH2, okay, this RNH2 bond will break up, and it will form RNH minus, that is a alkyl amide ion. Okay, alkyl amide ion will be formed out here, and this NH2, okay, if this NH2 will be attached out here, which is having a protonated imide here. It is acting as a protonated imide. So further this hydrogen bond will break, and it will get attached to the amine here to form the alkyl amine, that is 1-degree amine, and the formation of thalamide will take place. Okay, again the formation of thalamide will be taken place here. So hence we will obtain alkyl group, here, and the formation of thalamide will take place here. So this is the thalamide, Gabriel thalamide synthesis. So after Gabriel thalamide synthesis, the next is the reduction of reduction of azides. Reduction of azides. So in the reduction of azides, first we have to form out the azides. So the formation of azide, the production of azide is taken place when alkyl halides are reacted with sodium azide. Okay, well, alkyl halides are reacted with sodium azide, then the formation of alkyl azide will take place and sodium halide will be removed out here. Now this alkyl azide is reduced in the presence of lithium aluminium hydride or amalgamated sodium in ethanol. So here we will obtain alkylamine with nitrogen gas. Also, we can use catalyst as palladinated charcoal, where the reduction will occur and formation of amine with nitrogen gas will take place here. So here, what is the main mechanism for the reaction? So here we will see that Na plus and N3 minus will be there. Okay. And the partial positive and partial negative charge will be there for the alkyl halides here. So here the reaction will take place between the compounds here and the formation of azide will take place here where two lone pairs of electrons will be present at the azide group here. Then further on reaction with on reduction with either palladinated charcoal or lithium aluminium hydride, the R, it will get attached to two hydrogens and nitrogen. Okay, here this nitrogen, it will get attached to two hydrogens and this bond will break up here and the formation of nitrogen gas will take place. Okay, and the formation of amine, that is primary amine, will take place here. Primary amine will take place here. Okay, next, preparation of amines by reduction of oximes also can be taken into consideration. Okay, so first we have to see what are oximes. So oximes are the compound where nitrogen is attached to the hydroxyl group. So on reducing the oximes in the presence of strong reducing agents such as lithium aluminium hydride or sodium in ethanol, we will obtain 1-degree amines. Okay, 1-degree amines can be obtained out here. Next, if ketoxime is there, okay, so here these are known as aldoximes. Okay, and here one example I am taking CH3CH NOH on reduction in the presence of lithium aluminium hydride, sodium in ethanol will give ethane amide plus water. With ketoximes, okay, with ketoximes also we will obtain the amides on reduction of ketoximes in the presence of lithium aluminium hydride, sodium with ethanol. Here also 1-degree amine will be obtained. Okay, here also 1-degree amine will be obtained out here. So this is the reduction of oxide. Next, by amination of aldehydes and ketones. By amination of aldehydes and ketones. Aldehydes and ketones. Okay. So here reduction will be taken place here, and also we will amination of the aldehydes and ketones will be carried out here. So here when aldehydes are undergoing amination in the presence of heat, so the removal of water will take place and imine will be formed out here. Then on further hydrogenation in the presence of nickel, we will obtain amines. That is 1 degree amine will be obtained out here. Similarly, if we are considering the ketones, there also the amination will be carried out when we heat the ketones, and here the formation of dialkyl ketimine. Okay, ketimine will take place, and on further reduction here we will obtain CH2 NH2 R dash. Okay, that is also a 1 degree amine. Okay, this is also called as reductive amination. This reaction is also called as reductive amination. The next preparation method is the Smith reaction. Smith reaction. So in Smith reaction, carboxylic acids are reacted with hydrazoic acid. Okay, in Smith reaction, carboxylic acid are reacted with hydrazoic acid, that is NH3. This is hydrazoic acid in the presence of concentrated H2SO4. So the formation of amine with carbon dioxide and nitrogen gas will take place here. Also, in the place of hydrazoic acid, we can use sodium azide, okay, and combination of concentrated H2SO4 also. Now, the next method is the industrial preparation for the amines, and in that the first is the from alcohols, the industrial preparation of amines from alcohols. So for the industrial preparation of amines from alcohol, first is the Sabatier and Mailhe method. Sabatier-Mailhe method, where ethanol is heated with ammonia at 723 Kelvin temperature in the presence of aluminate to form ethane amine. Further, if the reaction carries out, then the formation of 2 degree amine and further formation of 3 degree amine will take place here. Okay, so the different 3-degree amines, different amines which are produced out here, they can separated by, they can be, the amines can be separated by fractional distillation. Okay, they can be separated by the fractional distillation method. So this was the industrial method for the production of the amines by using the Sebestier-Meillet method. Next, physical properties of amines. Physical properties of amines. Okay. So in the physical properties of amine, the first is the physical state and smell. So lower members of aliphatic families are gases. Okay. So lower members of aliphatic amines are gases. Okay. And smells like ammonia. Smells like ammonia. While the higher members are liquid. Okay. Higher members, higher members having more than 3 carbon atom are liquid. They are liquid with fishy smell. Okay, with fishy smell. And the further higher are solids. Next, the boiling point. Amines have amines have higher boiling point, higher boiling points than the respective hydrocarbons. Okay, due to inter hydrogen bond, inter hydrogen bonding. Okay, while in the case of tertiary amine, this hydrogen bonding is not possible. So we will see that the tertiary amines are having lower boiling point as comparison to that of the primary amines. Okay, next, third, solubility. Solubility, lower aliphatic amines, lower aliphatic amines are soluble in water, are soluble in water as they can form hydrogen bond with water, hydrogen bond with water molecules, with water molecules. Okay, while while higher amines are insoluble in water, but they are soluble in other so, other solvents such as CS2, CCl4, etc. Now, let's talk about the chemical properties. Chemical properties of amines. And in this first, we are going to see reaction with water. Okay, to show the basic character of the amines. Reaction with water. So, when amines are reacted with water, so the formation of hydroxide amine, okay, hydroxide amine will take place where on further reaction we will obtain hydroxyl group, okay, and a protonated amine will be formed out here. So here, as you can see that a proton is been accepted out here. So here the amine is acting as a Bronsted-Lowry base. Okay, Bronsted-Lowry base, while the water is acting as a Bronsted-Lowry acid here. Also, if you are going to compare the amines here, so we will see here that the basicity of amine, okay, the basicity of amine, it is decreasing with the more number of alkyl group attached to it. Okay, here we will see that the secondary alkyl, the secondary amines, okay, the secondary amines, they are having more basic nature as comparison to that of the sorry, they all are 1 degree amine only, but here when N amines are there, they are having more basic character as comparison to that of the N amines and as comparison to that of the NN triethyl amine. Okay, while in the case of while in the case of ethyl amine, the same relationship will be followed out here. That is, it will just change out here that the lowest basicity will be possessed up by the ethylamine as comparison to that of the ethyl tri NNN ethyl triamine and NN ethyl amine. Next chemical property is reaction of amines with acids. Reaction with acids. So as amines are having basic behavior, so we will see here that they when they are reacting with acids, for example, methylamine is reacted with hydrochloric acid, so it will form methyl ammonium chloride. Okay, it will form methyl ammonium chloride, which is a salt. Similarly, when aniline is reacted with hydrochloric acid, formation of aniline hydrochloride, anilinium chloride will take place. Next, reaction of amines with reaction of amines with transition metal ions. Transition metal ions. So first, if silver chloride, okay, is reacting with amine, that is methylamine, then here a soluble complex salt, that is soluble complex salt of silver and amine will be found out here. Okay. Similarly, copper sulfate, when reacted with amine, so the formation of soluble, copper soluble complex will take place here. And here it will be having a deep blue color as comparison to that of the blue color of the copper sulfate. And here for the amine complex, silver amine complex, the formation will show that the precipitation of AgCl will be changed out there into soluble complex here. So this will be the indication of this compound formed here. Next is the reaction with the alkyl halides. Reaction of amines with alkyl halides, or it is also called as alkylation. So when amines are reacted with alkyl halides, so here the nitrogen, okay, it will act as a neutral nucleophile and it will attack on the carbocation of the alkyl halide to form a salt. Then with the use of base, here the removal of halide will take place and the formation of 2-degree amine will be taken place here. Similarly, if this reaction is continued further with one more molecule of alkyl halide, then the formation of tertiary amine will take place. And at last the formation of quaternary ammonium salt will take place here. Okay, quaternary ammonium salt will take place here. So this is the exhaustic alkylation. This is called as exhaustic alkylation. Okay, this is called exhaustic alkylation. Next is the acylation of amines. So the nucleophilic substitution, okay, reaction between the acyl chlorides and amine will take place in the presence of a base. Then the formation of substituted amide with hydrochloric acid will take place here. Similarly, if amines are reacted with acetic anhydrides, sorry, not acetic, this is acid anhydrides, then the formation of substituted amide with carboxylic acid will take place here. And if 2-degree amine are reacted with acyl chloride in the presence of base, then the formation of substituted amide will be taken place here. Okay, so here taking an example for CS3 NH2 with acetyl chloride here. So the formation of HCl will take place and the left out compound will attach with each other to form substituted amine, that is N-methyl ethane amide. N-methyl ethane amide. One more example for the acetyl chloride where 2-degree of amine is reacted with acetyl chloride in the presence of base, here the formation of HCl will take place, and NN diethyl NN-diethyl ethanamide will formed out here. NN-diethyl ethanamide will be formed out here with HCl. Okay. So what is the mechanism for this reaction? So here ethanamide, for example, if I am considering the ethanamide, it is undergoing the nucleophilic substitution reaction here, and the nitrogen it will attack towards the carbocation of the carbonyl group here. Okay, and due to this reason the formation of a intermediate compound will take place. Okay, further, as positive charge here present with the nitrogen, so electron density will decrease on the carbon here, and the chlorine it will be removed out here. With this negative charge on oxygen, it will be donated to the carbon atom here to form the amide group here, and the removal of HCl will take place here. Okay, this H and this Cl will add up with each other to form HCl. Now the left out compound it will rearrange itself to form the amide. Okay, and HCl will be released out here. So this is the acylation of the acylations of the amines. This is the acylation for the amines. So for today I am ending the class here only, and in the next class we are going to discuss about the benzoylation, Skiff's base formation, and further more reactions related to the amine here. Okay, so for today I am closing the class here only. Thank you.